The Fung double chip system is a very simple method, so we finished talking about this. We introduced this new effective method for you to use in the laboratory. You will work a lot more to show you how it works. This is just a review of some conversion diagnostic kits that I've been working with in the lab. And we may be using some in this workshop, or we may not use some of these. We just talk about some of these diagnostic kits for general information for the workshop like this. API system, we all know them very, very well. It's a very long history of 30, 40 years, basically, on the API system. And basically, it's to identify Proteobacteriaceae and other gram-negative organisms. There are 23 standard biochemical tests in this tube. And all you can do is put a suspension of organism in 0.85 salinity, semi-liquid. And then you suspend them into the microtubes. Make sure you fill it up correctly. And then you overlay with unfilled tubes with mineral oil so that you make it anaerobic or at least no contamination. Incubate at 18 to 24 hours at 35 to 37 degrees C. And you can read the sugar reaction, or sometimes you need to add some reagents, and you record the reactions. And this system has been around for a long time. It's still very useful and very important. Well, all of you have seen this before. If not, this is the 16 differential test strips available. And there are all kinds of organisms that they are testing. So this system is very popular for a long time. And I think it's still very good system to do individual testing of organisms. So API system has been a long time great success story in applied microbiology. EnteroChip is a very interesting system. Also, this is you can use it for Enterobacteriaceae. It's a self-contained compartmentalized tube. It has 12 conventional tests. One thing important for microbiologists is microbiologists are old-fashioned people. They don't know how to change things immediately. If you want to change something, you still need to go back to the conventional method to make sure that it works. But we'll show the tube here. I'm sure some of you have seen them, or maybe all of you have seen them. And you have to unscrew the caps, and then interestingly is you make sure that you know which part is to touch the organism, which part is not touching the organism. So very carefully touch the needle, and then you can pick the polymer and you can twist it around and go through all the compartments. Well, we did a lot of these things and train students how to do it carefully. And then the EnteroChip has been around for a long time and it's still very persistent. Then you can read the reactions for up to 24 hours. Incidentally, a lot of tests started in microbiology with 48 hours. The Reaper students, a long time ago, all these tests took 48 hours, and then you changed it for 24 hours. Now the tests are 4 hours. Now, most of the tests right now will finish in 4 hours. Well, the best is instantaneous also. Mainly right now the target is 4 hours. If you want to be successful, you've got to get something in 4 hours. At the beginning it was 48 hours, 34 hours, 12 hours. So 4 hours is the peak for the time. This is the historic, going around for many years now. It's an EnteroChip. So we have two sides, and these are all the tests that we run. That has been very successful for a long time. Another system is called the microID system. MRAMA is a company that developed a lot of these tests. They test the Enterobacteriaceae. Again, one of these tests is, if you want to be successful, you have to be successful on Enterobacteriaceae first, because that is the money-making type of test. So if you can do Enterobacteriaceae well, then you can sell a lot of these tubes, and then you can move on to other organisms. The first group of organisms people test market is Enterobacteriaceae because of the possibility of foodborne diseases and health problems. And there are 15 chamber tray with interest couplers. Then you can use this and it has a different modification. The chambers containing substrate and detection disc, you prepare the pure suspension, and then you add. By the way, if you add things into the chambers, it must be very precise. It's 0.2 mil to each chamber. If you add wrong, then you have different results because of the volume involved. So it's very important. Even with all these rapid methods, they all should still think of themselves as a microbiologist, or just somebody to press a button and get the result. So taking care of the microorganism is still the most important part. That's why we train students to strip away, quality, gram staining, all this stuff. It's very, very important. And then also you need to learn how to add reagents in to the special wells. You do not want to make a wrong well, then the result will be not accurate. And we have to be trained to run these tests carefully. I think in this workshop we did test the micro-ID before. I don't know whether we are doing it right now or not, because there are many more easier tests to run, but this is classic. So this is the micro-ID test. And I have done a lot of these things in the laboratory. And it's about 4-hour test or 6-hour test depends upon the panel. And you can get an answer in 1 morning. That is quite rapid. Crystal ID, that's another test. It's called a BBL, bacterial. Then they have a gram-negative organisms. You can test about 30 different gram-negative and gram-positive. It's 4-hour test. The bacteria is suspended into a carbon 0.5 scale to make sure. Another thing is you have to use the organisms at the right timing of incubation, 12 hours. If you use that as 12 hours, then always it must be 12 hours, or else you cannot compare data. And then you pour the liquid in well carefully, and make sure you inoculate it with all the wells. And you can incubate it, and after the right time, then you can read and tabulate the data. So this is the crystal EBL system, and after you do the experiments, then you can actually do the reading with the machine to read. At the beginning, all the readings are by your own eyes, but after you will start to see, well, why do we use a machine to read it, and it's more reproducible, it is easier. So you can have a machine to read the data. Now with computer, you can do a lot of analysis quite quickly. There's another system called the rapid ID. One is called made by the MRAMA company. It's quite near our university, the main company. So go there to work with them. And the MRAMA has a antibacterial ACV test for gram-positive, negative, gram-negative raw. And the reaction can be in about 4 hours, depending on how they do that. The procedure is suspend bacteria in inoculum fluid. This is also important that you should have the right amount of organisms in the system. If you have not enough, too much, then the data is not comparable with the standard data. So be very careful that you have to put the exact amount in exact tube to make sure you get all these things done. All right, and then you have to look carefully, put things in. You can do rock and roll, make sure all the liquid fill in carefully. So you need to make sure you have distributed the liquid into the system very well. Again, nowadays we are talking about 4-hour test. 4-hour test is a standard at this moment. As I said a long time ago, 12 hours was a standard, but now all the tests you must do in 4 hours, or else you will be outcompeted by your competitor. I think pretty soon we are doing 2 hours of instantaneous. So this is a one system called rapid ID1, and you can read the results and do the calculations. There's a rapid NR2. This is the anaerobic for anaerobic organisms. This is similar to the one except that we use different configurations, a number of organisms. The culture should be taken off the medium containing 5 to 7% sheep blood powder. There's another thing that you need to have a pure culture. This is important to mention that too. That you must have one pure culture to do the experiment. If the culture is not pure culture, and you'll be doing 2 organisms with the same quality, then the data will be meaningless. So you have to know how to strict a pig carefully. That's very, very important. So this is the rapid one system, and they modified it to make it easy to inoculate. So this system is, in a lot of workshops, we run this type of system. Vitec, of course, is a big company, they have orders of fantastic systems. In the workshop that I ran for many, many years, I was still running it in different ways. So we went through all these things. Our workshop in Manhattan, Kansas, at the beginning was 2 weeks. People became very good friends after 2 weeks. But we ran a lot of tests, and we went through all these things very, very carefully. And then we took the unknown culture and put it into the chamber and make sure everything is perfect. And then we incubate for 4 to 12 hours. In those days, 12 hours was a standard, but now it's 4 hours. And the instrument will scan the color change or gas production against the case. And then you can actually, typical E. coli, you can identify in 2 to 4 hours. Carefully. There are actually a few thousand units being used around the world. The Vitec system has been a very successful system, especially good for clinical isolates. Of course, all this we are doing food microbiology, water microbiology, but a lot of these tests were first done in the hospital because people die if you don't treat them carefully. So the golden standard in the hospital is 4 hours. You must have a good intake in 4 hours so that you can treat the patient to save their lives in many cases. And these tests really save a lot of lives in the past many years. So this is the Vitec system. Here was a very company, a famous company. But the starting point is about $50,000 to get everything started. But once you get started, then of course the unit is not that expensive. Another thing is hospital. They run tons of data every day. So they have to save patients' life. That's important. In 4 hours, you can find out the organism, then you can treat the patient much, much easier. Biolog, this is another interesting thing. When I was a student, I can say that I was looking at all these test tubes like crazy, and then when I saw this microbiology plate, they just got started at that time. Then I started thinking, why do we do things in this little microbiology plate? Then we started to do a lot of things in the microbiology plate. Biolog is also a system that uses the microbiology plate to do these things. And we have the culture, which the microbiology plate will identify different carbon sources and will control and get a lot of work. It's integrated overnight, and then we can look at the color patterns, observe, and compare with the profile. Of course, nowadays we have computers to want to do all these things. But something we still should go back to the original, make sure that you understand you're doing the pure culture. Another important thing is the culture must be pure, or else all the data will be meaningless, literally meaningless. So we still have to be good microbiologists, aseptic technique, picking the quality, all kinds of stuff that you all know, I'm sure. But then in the biolog, we use different carbon sources, different organisms, we use different things, and of course, the computer will help a lot in our identifications. The instrument can scan plates and conduct matches of identification. And another thing is you have to have many generators to generate good data so that people can send samples into your system, your lab. You should have a very good database so that you can match them carefully. They study 1,400 genera species, and there are a lot of work done in biology for a long time. So this is a big chamber, this omni-log system, fully automated. And they organize to tell you the price is $57,000 to start the whole thing. But when you start using it a lot, then you can get your investment back in terms of the sample that we analyze. Okay, I finished this talk here. Let me see, do we have time about America now?
Maybe tomorrow?
Okay, all right. So, I'm done here, but if you don't mind. No. Sure.
Thank you.